19.2 question 6. ADBO. There we go. ADBO is a parallelogram. OBED. OBD is also a parallelogram. So without any further ado, if that's A, then that is also A. If that is B, then that vector A to D is also B. If that is B, and this is a parallelogram, then C to E is also B. And if O to C is little c, then B to E is also little c. I've now filled the diagram with little vectors before I've even read the question. Right, now maybe we can do a question. What is O to D? Well, O to D is going to be A plus B. Very straightforward, isn't it? Nothing hard there. B to C in that direction. B to C. Well, we go along here, B to E, then E to C. So we're going to go C, then minus B. That will connect B to C for us. So C minus B. A to B, straight across there, very simple. A to B, we can go A to D, then D to B. In other words, B minus A. Or B minus A, yeah, it's good, it's already in the right direction. So B minus A. And B to E, that's that one from there to there, but I've already written it in the diagram anyway. It's directly parallel to the OC because I'm told it's a parallelogram. So B to E, straightforward, that's C. What about D to C? I've got to go from D, I mean loads of ways of getting there. I can go down here, then across. So why don't I do that? Or I can go down here, and then down. So very easy. Let's go one route. Let me write it out because it's a little bit long, this one. I want to go D to C is going to be D to A, followed by A to O, followed by O to C. And as always, we start with the letter we want and finish with the letter we want. Now just substitute the vectors. So D to A is going to be negative B, because against the flow of traffic. A to O is a negative A, we're coming against the A, and O to C is just C, because we're in the right direction. So I'm going to call this one C minus A minus B. So there it is. And I just want to show you that this works as well very quickly. So D to B is going to be minus A, D to E is going to be plus C, and E to C, that takes us from D to C finally, is going to be minus B. And there it is again, minus A, minus B and plus C. That's the three ingredients there, so it's correct anyway. Alright, yeah, that's that. Now, F is a point, this is confusing, such that OF is A plus B plus C. I don't know where it is on the diagram. It could be A, B, and C could be across here somewhere. It has to be parallel to this C anyway. That's one way of doing it. But anyway, write CF in terms of A, B, and C. Now look, I've got CF and I'm going to play with OF as well. How about if I go, let's just think carefully. CF in the direction which is specified has to go C to O, followed by O to F. Okay, so I don't know where F is, but I know mathematically C to F can be accessed by going from C to O and then from O to F. And I'm told what O to F is, and I know what C to O is anyway, because C to O, or CO, is negative C. So we can substitute. So CO is going to be minus C plus whatever O to F is, which is A plus B plus C. What have we got? Well, minus C and plus C cancels. I'm left with the answer A plus B. And that's what CF is. And I think I'll pause there. I might stick question 7 onto it as well, or do it as a separate video, I don't know. I might pause and just save it, just see how we feel about it. Section 19.2, question 7 on page 285. It's going to be a challenging one. What do we got? Triangle XYZ. What's a triangle? M is the midpoint of Y and Z, so M's right in the middle, and S is the middle of X and Z. And I'm told that X, Y is called vector A, little a, and X to Z is called little b. And while I'm at it, if S is the midpoint, let's just fill up the diagram a little bit better. X to S must be 1/2 of a B vector, and the other half, Z to z to s to z rather must also be half a b. Right, so that's set up. I'm told that these two lines cross at a point called R, it says so right there, and the ratio of xr to rm is 2 to 1. In other words, that's going to be twice as big as that part there. So if you imagine we got, say, 3/3 of the entire vector mx, x to r would be 2/3 of whatever the vector is, and r to m would be 1/3 whatever the vector is. So this is me setting up the picture. Alright, set up the vector diagram rather. Right, let's just jump straight in. What is y to s? Well, y to s goes from there to there, so in order to access it, we have to go down this route, y to x, which is minus a, and then we have to go x to s, which is plus half a b. Is that alright? So y to s is going to be minus a plus half a b. Easy peasy. Or half a b minus a, makes no difference. It's okay if you leave it like that. Now we want to go from z to y. Now z to y, how do we go from z to y? Well, we go from z to x, which is minus b, and then we go from x to y, which is plus a. And of course you could have written a minus b, makes no difference there. Next one, z to m. How do you get from z to m? Well, I know that z to y is minus b plus a, so z to m is going to be half of minus b plus a, or half of a minus b. So let's write the other half here as well, in case we need it later on in our journey across this little vector map or vector diagram. So what do we got then? Z to m, how do we go from z to m? It's simply half of the journey from z to y, so write it straight in. So that's a half of minus b plus a. X to m, where's x? Right, x to m is very straightforward now. We go from x to z, which is an entire b. I better do it here because I need to calculate some things. So let's do it fully. X to m goes from x to z first, that's the journey, and then we're going to go from z to m to finish the journey off. Alright, and as you can see, we're starting with x and finishing with m, which is exactly what this vector is. Now substitute the letters. So x to z is a complete b, plus z to m is going to be a half of, let's call it a minus b at this stage now, and then begin to simplify. So we have got b plus half an a multiplying out, minus 1/2 of a b, and we've got b minus half a b, which is a proper half b, it's not negative, it's positive, plus half an a that's still there, factorising and simplifying, half lots of a plus b. So that's x to m then. I can't really fit that in, but anyway, if I was to write that, that would get very, very awkward. Right, let's just write it here, there's a final answer. So it's going to be half of a plus b. Right, now x to r. Well, I know x to r is going to be 2/3 of vector x to m, so I said this previously, alright? So x to r is question 5, make it fit here. So x to r is going to be, because the ratio of 2 to 1, it's going to be 2/3 of whatever x to m is. Is that fair enough? I don't really need the bracket, but it doesn't hurt. Let's begin to do the maths. It's going to be 2/3 of this one, 2/3 of a half of a plus b. Don't need to multiply anything out. That becomes 2/6, which is a third. Essentially, it's a third of a plus b. Alright? So x to r is a third a plus b. So let's write it in here. And now x to s. Well, I know x to s is half a b because I've already labelled it on the diagram quite early on in the question. So straight away, that's a half of a b. Now we're going to do r to s. Okay, so we go from r to s in that direction. Not very difficult. So let's just work it over here. Question 7, or rather part 7. How do you go from r to s? Well, let's state our claim. R to s, we can go from r to x, can't we, first, in the direction specified, and then we're going to go from x to s. and we know we're going to get it right because we're starting with R and finishing with S. We just need to substitute the correct vectors. Now, R to X, where's Rx then? R to X, well, X to R is a third A plus B. Therefore, R to X will be minus that. So it'll be minus 1/3 of A plus B. And then I want to add on what X to S is, which is 1/2 of a B. Now, we've got our marks, but not all of them. We've got to multiply out and simplify, and that's what we have to do. So let's just do it here. Multiplying out then, minus 1/3 of A minus 1/3 of B plus 1/2 of a B. Now we're just playing with fractions. Right, so A's on its own, so it's minus 1/3 of an A. Now, minus 1/3 of a B plus half a B. Let me fully do it. We have to play with common multiples on the denominator. That's going to be minus 2/6 of a B plus 3/6 of a B. Again, you can do this in your head, but it's risky and it's a little bit out of context. You're not used to doing fractions in the context of vectors. It's the first time we've come across in this kind of detail. We have to manipulate the thirds and the halves. So, minus 1/3 of an A stands alone at the moment. Now, minus 2/6 plus 3/6 is in fact 1/6 in the positive direction. Alright, so it's plus 1/6 of B. Now I can take this further. I can factorise it by taking a 1/6 out at the moment. That will give me minus 2A, because a 6 times minus 2 is minus 2/6, and minus 2 over 6 is minus 1/3. And if I've taken a 1/6 out of B, it's just a plain B, isn't it? Is that alright? So I can leave it like that, or I can go minus 1/6 and then manipulate this a little bit further, and it would in fact be 2A minus a B. But I'm happy with that. We've tinkered around enough with it. Let's just write here anyway. So if I have to take the negative out, it will be minus 1/6. So it will be 2A minus B, because minus minus become a positive 1/6. So I put a little box around that, and as a potential alternative. I don't know which one will be better in the end when we come to use it in the next part, but these are both equivalent to each other. In the exam, please don't give two versions, just give the one that you're happy with and work with it. So let's just write up the answer there. So I'm going to write the first one, because that's the one I got first. It's going to be a 1/6 of minus 2A plus B, or a 1/6 of B minus 2A. Doesn't matter at all really. Now, question 7, sorry, not question 7, question B involves using parts 1 and part 7 to get a very difficult question here. So I'm going to go for that and that, and I might need an extra page on this. So what I'm going to do is add a page now and step back. Now, it says use your answers to 1 and 7, so at least they're giving us some hints, to calculate the ratio of YS to RS. Alright, so let's go all serious and blue. In fact, I've forgotten it already. What is it? YS, RS. So the ratio of YS to RS. And what's that going to be? Well, let's just write down the vectors. Well, YS is minus A plus half a B. So that's going to be minus A plus 1/2 of a B. Ratio sign. And this is going to be 1/6 of, I've got to do it in parts as I will forget it, 1/6 is minus 2A plus B. Let's just go back and check it, because if I get this wrong, the whole thing's wrong. Alright, so that's that. Now I've got to simplify that ratio. It looks awful, doesn't it? Well, I really do not like playing with 1/6. I really don't. What I'm going to do is multiply both sides of the ratio by 6, and at least I'm playing with whole numbers on each side. So if I multiply this by 6, I've got 6 bracket A plus half a B, compared with, well, the bracket's now gone, hasn't it? It's just minus 2A plus B. Multiplying out, I've got minus 6A plus 3B's, compared with minus 2A plus a B. Oh look, I believe I can factorise this left hand side. I can take out 3's out of this, or even minus, let's just take out a 3 first. I've got 3 lots of minus 2A plus a single B. This is ordinary factorisation now. The fact that we're doing vectors is almost a coincidence. We're just factorising a little bracket, and that's with minus 2a plus b, and look, we have a common vector, minus 2a plus b, minus 2a plus b, so we can quite happily cancel that, which is beautiful, and the ratio is 3 lots of that vector to 1 lot of that vector, and that is very handsome indeed. That's definitely worth an A star. In fact, it's gone off the scale beyond A star, because well, it doesn't say A star next to it, it's just a massive great vector, and I'm really happy with that question. It's quite complicated, especially when dealing with fractions. So I'm now going to jump into the assess and do a few of those, well, quite a lot of them really, because vectors are quite tough in places, and I'll catch you very soon. So you look at that one, it's a real beaut.